Hello out there, welcome back. We're still looking at application to counting principles, okay? And remember, when you're doing a counting principle, remember we have choice with repetition and choice without repetition. Just pay attention to that, repetitions without repetition. And now we apply that in probability. Let's see what kind of a problem we have for you. Okay, so there is a problem. So I encourage you to read the question very carefully, okay, and really understand that before you look at the questions. So every client of a certain bank has a personal identification number, which is called PIN, okay, which consists of 4 random digits, very important, chosen from 0 to 9, okay? Make sure you understand the question. We're talking about a PIN, which is 4-digit, okay, number, but those digits are chosen from 0 to 9. Are we together? Makes sense. Now, what does the first question want us to do? How many PINs can be made if the digits can be repeated? Digits can be repeated. It implies I can use 9999. And so on. I can use 555 4 times because I can repeat the digits. The second question, how many pins can be made if digits cannot be repeated? So the second one now, you cannot repeat the digits. If I've used 5, I cannot use 5 again. If I've used 9, I cannot use 9 again. So you cannot repeat the digits. Then followed by what? If a PIN, this is the application of probability now, if a PIN is made by selecting 4 digits at random and digits can be repeated, okay, what is the probability that the PIN contains at least 1 8? Okay, interesting question. Then our last question, if a PIN is made by selecting 4 digits at random and digits cannot be repeated, what is the probability that a PIN contains at least 1 8? Are we together? Fantastic. Let's see how we can tackle this. So it's still the same problem. Okay, remember we're working with 4-digit PIN and we have to choose digits from 0 to 9. The first question, how many pins can be made if digits are repeated? We definitely can have. If digits can be repeated, we have 10 digits. Remember, 0 to 9, you have 10 digits, okay? Because we're counting 0 all the way to 9, we have 10. If you're counting from 1 to 9, you have 9 digits, but we're including 0 as a digit. Hence, you have 10 digits. So 10 digits, we have to choose from where? 0 all the way to 9. You have to choose 4 digits. Then the number of possible pins. So the first position, we can choose what? 10, because we have 10 choices from 0 to 9. And the second one, we also have 10. And the third one, we have 10. And the fourth one, we have 10. And you multiply, you get 10,000. Or you can leave your answer as 10 to the power of 4 in an exponent form. Here, we could repeat the digits. Okay. Let's look at the second one, which actually restricts us. We cannot repeat the digits. Okay. So still the same problem. Remember, we're talking about a 4-digit pin, okay? And from where? From which numbers? 0 to 9. Very important. How many pins can be made if digits cannot be repeated? Very important. We cannot repeat digits here. So let's look at this. If digits cannot be repeated, you have 10 digits for the first choice. Are we together? Then 9 for second choice, 8 for third choice, and 7 for the fourth choice. Are we all together? We have 10 for the first choice. Are we together? Followed by 9, 8, then 7. And by fundamental principle of counting, we multiply those numbers together. Okay, let's see what we have there. There we have. Therefore, the number of possible pins will be 10 because we have 10 digits to choose from for the first. Then we have 9 because we cannot repeat. We already used 2. We have 8 to choose from. Then we have 7 to choose from because we already used 3. Are we together? Then if you multiply, that's what we get. Okay. Those are the total numbers of pin if we use digits from 0 to 9, and repetition is not allowed. Okay? Just remember to pay attention. Repetition allowed and repetition not allowed. Fantastic. Okay. Let's look at this third and the fourth, where actually contains some probability. So the third question, we're still dealing with a client from a certain bank, okay? So remember, we're dealing with a PIN, which consists of 4 digits, which are random. And where do we choose the 4 digits? From 0 to 9. In 0 to 9, we're talking about 10 digits, numbers. So if a PIN is made by selecting 4 digits, okay, at random, and digits can be repeated, very important, repeated. Digits can be repeated. What is the probability that a PIN contain at least 1 8? It must at least have 1 8, your PIN. So what is the chance of choosing that PIN? Okay. Remember the probability, it's what? Okay? It's the event over divided by the possible outcome. So we'll have to use our counting to calculate our event and an outcome, and able to divide both and calculate the probability. So firstly, we'll have to calculate how many pins with at least 1 8. That's what we have to do. And let's see how we can do that. So, if 8 is in the first place, are we together? Then the number of ways of arranging other 3 places is fine because we can repeat digits. So if we use 8 in the first digit, we still, okay, we have 10. Then we have 10 times 10 times 10, because remember, repetition is allowed. Are we together? If 8 is in the first place, the numbers of ways of arranging are the 3 places. Okay. Now, what about if 8 is in the second place? If 8 is in the second places, the number of ways of arranging other 3 places will have what? 10 times 10 times 10, which is also 10,000, remember, because repetition is allowed. Then lastly, if 8 is in the third place, the number of ways of arranging other 3 places will be 10 times 10 times 10 also, because we have 10, 10, 10, which we get what? 1,000. Okay. So if 8 is in the fourth place, the number of ways of arranging other 3 digits will be 10 times 10 times 10. Are we together? Which is 10,000. Are we together? Are we together? Because if you choose 8, it's only 1 8. Are we together? Then times 10 times 10 times 10. So we're thinking of 8, it could be in the first place, 8 could be in the second position, 8 could be in the third position, 8 could be in the fourth position. So we're just arranging 3 digits. Are we together? Fantastic. Then what do we do here? So the number of ways of selecting digits will be 1,000, 1,000, 1,000, 1,000, which is give us 4,000. Are we together? Because if you're 4 digit, 8 can be in the first place, second, third, or fourth. So there's 4,000 ways of doing that. Okay. Then now, how do we do the probability? Let's look at that. So the total number of arrangement in a set as calculated in the question 1 was 10,000. Okay, remember, which was 10 times 10 times 10, because it's 4 digits, and we can repeat, which was 10,000. Now, therefore, the probability that a pin contains at least 1 8 will be the 4,000 divided by a 10,000, which gives us 2 over 5, or 0.4, which is approximately 40%. Read together. This is an interesting question. So our fourth problem, okay, which is similar. So let's see what is required here. So we're still dealing with a pin, okay, which consists of 4 digits, okay, chosen from where? 0 to 9. Okay, we're still dealing with a digit, 4 digits, we choose from 0 to 9. What is the question here? If a pin is made by selecting 4 digits at random, and digits cannot be repeated, can you see, very important, digits cannot be repeated here. What is the probability that a pin contains at least 1 8? So we cannot repeat the digits. Okay, let's see. So if 8 is in the first place, okay, we have to think of 8 being in the first place, then the number of ways of arranging other 3 digits will be 9 times 8 times 7. Because if 8 is in the first place, it's only 1. So I didn't include that 1. So it's 1 times 9 times 8 times 7. Because we cannot repeat the digits. Okay. Then we think about, what if 8 is in the second position? So if 8 is in the second place, the numbers of arranging, okay, other 3 places will still be 9 times 8 times 7, because we cannot repeat digits. Similarly, if 8 is in the third place, the number of ways of arranging other 3 places will still be 8 times 9 times 8 times 7, which gives us 504. And lastly, if 8 is in the fourth place, the number of ways of arranging other 3 places will be 9 times 8 times 7, which is still 504. Okay, then which give us what? So the total numbers of selecting a digit will be 504 and 504. You add that 4 times, which give us 2016. Are we together? But the question was asking about the probability. And how do we do that? So the total number of arrangement in the set, as calculated also in question 1, was 10,000, was 4 pin, where what? Repetition allowed. Agreed? Which was 10 times 10 times 10. Are we all together? That there was a total sample space, which we had from the question 1. Now, a pin containing no repetition and numbers and at least 1 8, which is what do we have? 2016 divided by 10,000 from our question 1, and we get something close to 20%. You can leave your answer as a fraction or decimal or a percentage. Okay, fantastic, guys. Hope you enjoyed. So, hope to see you after the break with more problems.